Okay, we're looking at practice test 2, problem number 2. As I have stated before, if you want to get the best out of these problems, then every time I ask a question or I ask you to make a calculation, pause the video before I show the calculation, try it yourself, and then continue on with the video. All right, we have a truck driving up a hill, toolboxes on the back of the truck. And the question is, what is the greatest acceleration the truck can have so that toolbox does not fall off? So the first question to think about is, okay, what is it that's keeping the toolbox on the truck? What is it that is accelerating the toolbox? What force? Let's start by drawing a free body diagram for the toolbox. All right, we have a frictional force on the toolbox. That's what's acting to accelerate it. We also have a force normal to the toolbox, and then we have a gravitational force on the toolbox. Those are the forces associated with the object, the toolbox. I also draw the direction of acceleration. Why is the frictional force in the positive x direction? Okay, that is the force required to accelerate the toolbox. What are the x and y components of gravitational force? Well, the x component of the gravitational force is Fg sine of 10 degrees. The y component is Fg cosine 10 degrees. What is Newton's second law for the x and y components? All right, for the x components, the sum of the forces in the x direction equals the mass times acceleration. Notice, of course, that the acceleration here is in the positive x direction. It's only in the x direction. So writing out that equation, we have that F, the frictional force, minus mg sine theta 10 degrees equals the mass times the acceleration. Force being in positive x, gravity acting opposite that direction. And then we have for the y components, the normal force minus mg cosine of 10 degrees. What is the normal force? That's very straightforward. Using the y component, we find that the normal force is mg cosine of 10 degrees. What is the frictional force? Well, remember that the relationship between the frictional force and the normal force is the coefficient of friction times the normal force. We've already solved for the normal force up here, so it's the coefficient of friction times the mass times gravity times cosine of 10 degrees. What is Newton's second law for the x component? We have that the coefficient of static friction times mass times gravity times cosine of 10 minus mg sine of 10 equals mass times acceleration, where the first term on the left-hand side is for the frictional force, the second term on the left-hand side is the force of gravity, and of course the right-hand side term is the acceleration of the object. Let's solve for the acceleration. Solving for the acceleration, I can get it in terms of the coefficient of static friction times a gravitational term associated with the normal force, and of course the gravitational force associated with just the weight of the object. Finishing out, just plugging in the numbers, I get 6.02 meters per second squared.